All right. Let's dive into some really cool AI research.
Cool.
That's all about taking those already amazing AI image models and making them even better.
Oh?
You know, our listeners are always curious about like pushing the limits of what's possible with AI, right?
Yeah.
Even after these models are fully trained.
Right.
And get this.
Okay.
It's not about just throwing more data or bigger models at the problem.
Right.
It's about this clever technique called Inference-Time scaling.
Yeah.
Imagine, like, getting mind-blowing results from a smaller model
Right.
just by strategically using more computing power during the image generation process itself.
That's the really fascinating thing here.
Exactly. It's not about...
And this research shows some pretty wild results.
Yeah.
Smaller models using this technique can sometimes outperform those gigantic models that don't.
Right.
But before we jump into all the details, let's make sure we're all on the same page about the type of AI models we're talking about.
Okay.
Diffusion models.
Right.
I think our listeners are pretty familiar with how they work.
Yeah.
Reversing the process of adding noise to an image to gradually reveal a clear picture.
Right. So what's really unique about diffusion models is that they give us this flexibility in how much computational power we use during image creation. Right. Unlike some other models like GANs or VAEs.
Okay, so we've got our diffusion model all set up, ready to create some magic.
Okay.
Now, how do we actually apply this inference time scaling to make it work even better?
So the obvious answer might seem like just adding more denoising steps.
You would think so.
Yeah.
But it turns out that approach kind of hits a wall pretty quickly.
So you get diminishing returns.
You get diminishing returns, and eventually you reach a performance ceiling.
So if just cranking up the denoising steps isn't the answer, how do we break through that performance ceiling?
Well, the secret is in searching for what we call better noises.
Better noises.
To use as starting points for image generation.
So not all noise is created equal?
Precisely.
Interesting.
Some noises lead to much higher quality final images than others.
Okay, that makes sense.
It's kind of like if you're a sculptor and the noise is your starting block of clay.
Gotcha.
The right type of clay will allow you to sculpt a masterpiece, right?
Right.
But the wrong one might just crumble in your hands.
Okay, I like that analogy.
Yeah.
So the trick is to find those like perfect pieces of noise.
We call them golden nuggets of noise that unlock the best results.
But how do we actually go about finding those?
Well, that brings us to two key elements. Verifiers and search algorithms.
Ooh, okay. So two secret weapons in our quest for AI image awesomeness.
Perfect.
So let's start with verifiers.
Okay.
What are they?
So imagine you have a panel of judges at an art competition.
Gotcha.
They each have their criteria for what makes a great piece of art, right?
Yeah.
Verifiers are kind of like those judges.
Okay.
But they're pre-trained AI models. Sure. And they're designed to evaluate the quality of the images being generated.
So we're not just randomly generating images and hoping for the best.
No.
We're using these verifiers to kind of guide the process.
Exactly. And tell the model what we're looking for.
Okay, but wait a minute. Wouldn't relying too much on a single verifier sort of lead to the AI gaming the system?
You're exactly right.
Yeah.
That's a very important point.
Like it gets really good at pleasing that one judge.
Yeah.
But maybe it sacrifices other qualities in the process.
Exactly. We call that verifier hacking.
Verifier hacking.
Where the AI kind of learns to exploit the specific criteria of that verifier.
So it's all about finding the right balance.
Exactly.
Okay.
You want to use a diverse set of verifiers to guide the AI towards creating images that are both technically impressive and aesthetically pleasing.
Makes sense.
Now let's talk about those search algorithms.
Those search algorithms, you mentioned that they kind of help us find those golden nuggets of noise.
Exactly.
How exactly do they do that?
Think of it like the space of possible noises is this vast uncharted territory, right?
Yeah.
Search algorithms are our explorers.
Okay.
Helping us navigate that space.
So like different routes leading to different treasures.
Exactly.
Not for perfect noise.
What are some of the... So there are several approaches, each with its own trade-offs in terms of speed and effectiveness.
Right.
The simplest one is called random search.
Random search, okay.
It's like throwing darts at a dartboard.
Gotcha.
Hoping to hit the bullseye.
Yeah.
You just randomly sample different noises.
Okay.
And see what works best.
So it's not the most efficient approach.
It can be very inefficient.
Oh, especially if we're dealing with lots of possibilities.
For complex tasks.
Right. So
that's where our next approach comes in.
Okay.
Zero-order search.
Zero-order search.
It's a bit more strategic.
Okay, so instead of randomly throwing darts, we're using a more calculated approach.
It's like if you're a detective trying to solve a case, you start with an initial guess.
Okay.
And you gather clues.
All right.
You make small adjustments. Based on the evidence you find.
Okay.
That's essentially what zero-order search does.
So it's like a detective algorithm.
It's constantly refining its search.
Refining its search to try to find the best possible noise for the job. But a detective algorithm would probably take a lot longer.
It can be more computationally expensive than just random search.
Okay.
It's a trade-off
between
exploration and exploitation.
Exploration and exploitation, okay.
And there's a third approach that kind of tries to find a middle ground.
Okay, tell me about this third approach.
It's called search over paths.
Search over paths.
Imagine you're exploring a really dense forest, right?
Okay.
And you want to find the highest peak.
Yeah.
Instead of just wandering around aimlessly or meticulously examining every inch of the ground.
Yeah.
You choose paths that seem likely to lead you upward.
So you're kind of like strategically exploring.
Exactly, but also periodically reassessing your direction.
Gotcha.
Based on the terrain.
So I'm guessing each of these search algorithms has its own strengths and weaknesses.
Exactly.
Right.
The choice of which algorithm to use really depends on a few factors. The complexity of the task. The available computational resources. And the desired balance between speed and quality.
So it's like choosing the right tool for the job.
Exactly.
We've been talking a lot about like searching for noises and judging images.
Right.
But does all this like theoretical stuff actually lead to better results in the real world?
Absolutely.
Okay.
That's what makes this research so exciting.
Okay, good.
The researchers found that by applying these inference-time scaling techniques, they could achieve remarkable improvements in image quality.
So give me some concrete examples.
Okay. Well, for starters, they found that even a relatively small AI model using inference-time scaling could create images that rivaled those.
Wow.
From models hundreds of times its size.
So it's not just about having the biggest model anymore.
It's about using your resources wisely, strategically, to get the best possible results.
And the images themselves look different.
They do.
Yeah.
The images generated with inference-time scaling tend to have a different quality to them. They're often sharper, more detailed, and just more visually appealing.
Where can people see this?
If you take a look at figure 7 and appendices E.1 to E.3 in the paper.
All right, I'll take that out.
You can see the difference is pretty striking.
Okay, so what are the real-world implications of all this?
Well, we're talking about a significant leap forward in the accessibility and quality of AI image generation. Imagine being able to create stunning photorealistic images on your phone, all thanks to the efficiency of these techniques.
That would be amazing.
And the most exciting part is this is just the beginning.
I love that.
Inference-time scaling isn't just about making pretty pictures. It has the potential to revolutionize many areas of AI.
Like what?
Including natural language processing.
Oh, okay. So before we jump to natural language processing, let's just quickly recap what we've learned so far about inference-time scaling for image generation.
Sounds good.
Would you say that the key takeaway is it's not just about the size of your model anymore?
It's about working smarter. Not harder.
I like that.
And by strategically applying these inference-time scaling techniques, we can unlock a whole new level of potential in an AI image generation.
So now, you mentioned natural language processing.
Right.
I'm dying to hear how this inference-time scaling magic applies to language models.
Let's talk about it.
But first, a quick word from our sponsors. So, how can this inference-time scaling be applied to language models?
It's a really fascinating area with a lot of potential.
Think about those like chatbots and language assistants.
Oh, yeah.
You know the ones you interact with.
Yeah.
Sometimes they can be helpful.
Right.
But a little bit clunky.
Yeah, like they're just following a script. Right.
Exactly.
They don't really understand what you're saying.
Right. inference-time scaling could make them way more articulate and sophisticated.
So instead of just giving like canned responses, they could actually understand what I'm saying and respond in a more nuanced way.
Exactly. We're talking about AIs that can write stories and poems and even code.
Wow.
Fluency and creativity.
That would be a game changer.
Yeah.
So how does it actually work with language? I mean, we were talking about noise with images.
Yeah.
What's the equivalent for language?
It's not about searching for noise in the same way as with images.
Okay.
But more about exploring this like vast space of possible word combinations, sentence structures.
Gotcha.
It's about finding the most effective way to express an idea. So instead of pixels, we're dealing with words.
Right.
And instead of noise, we're looking for the right combination of words and phrases.
Exactly. Finding the most eloquent, the most insightful.
Human-like way of communicating.
Yes.
Okay, so are the same search algorithms used for images used for language models too?
Yes, a lot of the same principles apply. You can use random search, zero-order search, and search over paths to explore the space of possible language outputs.
Okay.
But there are also unique challenges and things to consider when applying this to language.
Like what? What are some of the challenges?
Language is inherently more complex and nuanced than images.
Right.
It's not just about finding patterns. It's about meaning and context and emotions.
That makes sense. So how do researchers account for all of that added complexity when they're working with language?
They're developing new techniques and algorithms specifically designed to deal with the complexities of language.
Yep.
For example, they're using techniques from natural language processing to better represent the meaning of words and sentences.
Right.
Which allows the search algorithms to navigate the language space better.
So it's like giving these language models a boost in their understanding of language itself.
Exactly.
To make their responses more meaningful and engaging.
Precisely. And the results are speaking for themselves.
Yeah.
We're seeing language models that can write different kinds of creative content.
Cool.
Translate languages with remarkable accuracy.
Wow.
And even answer complex questions.
Amazing.
Really, really impressive.
That's awesome.
Yeah.
So this is all super exciting. It feels like a paradigm shift in how we interact with machines. But are there any downsides?
Yeah.
I mean, what are the limitations of this technology?
Yeah, that's a really important question.
I mean, are there risks that these language models could become too powerful or too persuasive or too human-like?
That's a very important question, and one that researchers and ethicists are really grappling with.
Right.
Like any powerful technology, there's always the potential for misuse.
So we have to proceed cautiously.
We do.
So on a more optimistic note, what are some of the most exciting applications of inference-time scaling for language models? Where is this technology already making a difference?
Well, one area where we're seeing a lot of progress is machine translation.
Oh, wow.
Imagine a world where language barriers are no longer an obstacle to communication.
That would be amazing. To be able to travel the world and communicate effortlessly with anyone.
Exactly.
So are we talking about translation apps that are more accurate and nuanced than what we have today?
Exactly. We're seeing translation models that can capture the subtle nuances of language, preserve the meaning, intent of the original text.
Wow, that's really remarkable.
Yeah.
What about other applications? Like, are there ways this tech is being used to improve daily lives?
Absolutely. Healthcare, for instance. Inference-time scaling is being used to develop language models that can analyze medical records.
Wow.
Help assist with diagnoses.
That's amazing.
Provide personalized treatment recommendations.
So we're talking about AI that can understand our language and use that understanding to improve our health and well-being.
Exactly.
That's incredible. What about more creative applications? Can this technology be used to enhance, like, artistic endeavors?
Absolutely. We're seeing language models that can write poetry, compose music, and even generate code.
That's mind-blowing. It seems like the possibilities are truly endless.
They are, and we're just scratching the surface of what's possible.
Okay.
As researchers continue to develop new techniques and algorithms, we can expect to see even more amazing applications.
That's super exciting.
But, it's important to remember that we were talking about the potential risks and ethical considerations of this technology.
Right. With great power comes great responsibility.
Exactly.
So it's important to develop these AI systems responsibly to make sure that they're used for good.
I completely agree. It's important to remember AI is a tool, and like any tool, it can be used for good or for ill. It's up to us to ensure that these technologies are used to benefit humanity and not to harm it.
That's a really powerful message. Let's move on to the final part of our deep dive and explore some of those thought-provoking questions about the future of AI and what it means to design AI systems that are not only intelligent, but also ethical and aligned with human values. So we're back and ready to really dig into these big questions about AI and ethics.
Yeah, it's definitely an exciting time to be working in this field, but also a time for some real reflection.
You mentioned before that researchers are trying to design these AI systems so that they actually align with human values.
Right.
Can you unpack that a bit? What does it even mean to design an ethical AI?
Well, it comes down to how we measure the success of these systems.
Okay.
If we're only focused on accuracy or efficiency, we might end up with AI that can do things really well.
Yeah.
But without any consideration for the bigger picture, the human context.
Right, like you could have an AI that can generate a super realistic image.
Exactly.
But it might be technically perfect, but totally lacking in any kind of artistic merit.
It might not have any soul.
Yeah, or emotional depth.
Right. It's like the difference between a photo that's perfectly exposed and a photograph that actually tells a story.
That's a great analogy.
So that's where these verifiers come in.
Right.
They're kind of like the guiding principles that shape what the AI prioritizes.
Okay.
Instead of just focusing on those narrow metrics.
Yeah, like just accuracy or speed.
Exactly. We need to design verifiers that can look at the quality of the AI's output in a more well-rounded way.
Okay, so what would a more human-centered verifier look like? How would you design one?
That's a great question.
A tough one.
Yeah, it's a tough one.
Yeah.
One approach is to look to other fields for inspiration.
Okay.
Like psychology ethics, even art.
Interesting.
Imagine a verifier that could assess not just how technically good an image is, but also its emotional impact.
So like how it makes you feel.
Exactly how it makes you feel its aesthetic qualities, whether it tells a story.
It's like teaching AI to have good taste.
In a way, yes.
So how do you teach an AI about these abstract concepts like beauty or emotion?
One promising approach is to train AI on huge data sets of human-generated content.
Okay.
So, for example, you could train an AI on a massive collection of paintings.
Right.
Or poems or music.
And by studying all of that art,
exactly,
the AI could start to pick up on.
It starts to develop a sense of what humans find beautiful or meaningful.
It's like giving the AI a crash course in art history.
But instead of reading about it, it's experiencing it directly.
Wow. So then these AI systems could actually start creating their own art.
Exactly. Imagine an AI that could compose a symphony that makes you feel a certain way.
That's incredible.
Or paint a portrait that captures the essence of someone's personality.
It's like this amazing collaboration between humans and AI.
It is a true partnership.
But with all of these possibilities, we have to be cautious.
Right.
There are risks we need to be aware of.
For sure.
One of the big ones we hear about a lot is bias.
Bias is a huge concern.
Yeah, because these systems are trained on data.
Right.
And if that data reflects existing societal biases...
those biases can get baked into the AI.
So for example?
Like if an AI image generator is mostly trained on pictures of people with certain skin tones...
yeah.
It might have trouble generating images of people who look different.
That's a real problem.
It is a serious problem. And researchers are working hard to find ways to address it.
Okay, good.
They're developing techniques to spot and correct for bias in AI systems.
So that these systems are fair and inclusive.
Exactly.
But bias isn't the only issue, is it?
No, there's also the question of transparency.
Right. How do we know what's going on inside these systems?
We need to be able to understand how AI makes decisions.
Okay.
So we can spot errors.
Yeah.
Identify bias.
Right.
And make sure they're aligned with our values.
Like we need to be able to lift the hood to see how the engine works.
We need to build trust. And that trust comes from transparency.
I think that brings us to the really big question here.
Yeah.
What kind of future do we want to build with AI?
It's a question we all need to be asking ourselves.
Because this technology is so powerful.
It has the potential to reshape so many aspects of our lives.
So we need to be thoughtful.
We need to have open discussions about the benefits and the risks.
We've covered so much ground today.
We have.
It's been fascinating.
It really has.
From the technical details of inference-time scaling to these really big questions about ethics and the future.
It's clear that we're at a turning point.
AI is going to play a bigger and bigger role in our lives.
There's no doubt about that.
But we have the power to shape how that happens.
To make sure that AI is used to empower people.
Yeah.
To solve the world's problems.
And to make the world a better place.
Exactly.
So keep asking questions, keep exploring, keep imagining what's possible.
And keep believing in the power of human ingenuity.
That's a great note to end on. Thanks for joining us for this deep dive into the world of inference-time scaling.
It's been a pleasure.
It's a complex topic.
It is.
But hopefully we've shed some light on it today.
I hope so.
Until next time, stay curious.